This video is about relative error. It is based on the previous video, which was about absolute errors. So what is relative error? First, we need those two numbers again. The first number that we need is called the estimated value. So using notation, we denote it by VE. The subscript E stands for estimated. Estimated value has a couple other names: forecast value, prediction, approximation, or just a guess. So before you do a job, you are trying to guess the result, right? So that is just a prediction, just a guess. Like let's say tomorrow's weather, or 7 days from now, next week's weather, you can guess. That is your prediction, that is your estimated value. What about actual value? Actual value is observation. So let's say you are trying to guess tomorrow's weather, so that is your guess. Let's say sunny. Okay, so that is your estimated value. And then what about actual value? Actual value is when it comes to tomorrow, you go outside, take a look. Is that a sunny day, rainy day, or cloudy day? So, and then you make your observation. So that is your actual value. So VE stands for estimated value, and then V stands for actual value. So the relative error formula is equals to the absolute value of estimated minus actual. You take the absolute value of that to get rid of the negative, and then you take the difference divided by actual value. So let's review the difference between actual and estimated value. So in this problem, what I gave you is, before you take a test, you give me an estimation. So before you take the test, you have to tell me what do you think you will get on the test. That is estimated value. And then after the test, I will give you a score on your paper. That is your actual value. Now, in this problem, what I want you to calculate is calculate the relative error for me. All right, so let's do that. So the first one is, relative error. So that is equals to, we draw a fraction bar. So the absolute value of estimated minus actual divided by actual. So that is 0 divided by 80. That is equals to 0. So the relative error is equals to 0. So relative error, did you guess correctly? The answer is yes. Before you take the test, you think you will get 80 points. After you finish the test, you got 80 points on the test. So this is a perfect prediction, right? Perfect prediction. You think you will get 80. In fact, you got 80. So that is a perfect prediction. 0 error. So the relative error is equals to 0. Let's take a look at number 2. So number 2, we have relative error that is equals to fraction bar first. So we have 80 minus 95 and then divided by 95. So we have the absolute value of 15, negative 15 divided by 95. Take the absolute value, you get away the negative. So 15 divided by 95. So this one, let me just report every digit I see on my calculator. So when I take 15 divided by 95, I have 0.15797947368. Let me make sure I got this right. 15, 78, 94, 73, 68. And then usually you don't need to report the whole thing on your homework. So usually let's just keep 4 decimal places. So let's just keep 4 decimal places. Then that would be 0.1579, right? Because 9, you need to add 1 to the 8. So that is your relative error. You just keep the decimal. You don't need to convert that to percent, because in the next video, the percent error, we will convert this answer to percentage. All right, so let's do number 3. So number 3, we have relative error that is equals to 80 minus 60, absolute value divided by 60. So that is absolute value of 20 divided by 60. So that is 20 divided by 60. This is basically 1/3, right? When you take 20 divided by 60, you have 0.3333. And then 3333. It's just 1/3. So you keep 4 decimal places, 4 decimal places. That means you have to keep 4 digits on the right hand side of the decimal point. So that will be 0.3333. All right, so that is the end of this video. This one has some value, right? This one is not equal to 0. This one is not equal to 0. What does that mean? Not equal to 0 means your guess and the actual data, they are not the same. So this one, if you make a quick comparison, 0.1579 versus 0.3333, which one is bigger? This one is bigger, right? So which one is more precise? This one is 80 versus 60. This one is 80 versus 95. So this one, the difference is 15. This one, the difference is 20. So this one has a bigger difference, right? So this one has a bigger difference. That's why the absolute error is bigger. Alright, so that is the end of this video. As always, if you think my instruction is helpful, let me know in the comment below. Click the like for me. Appreciate your help. Subscribe to my channel. I appreciate your help as well. See you all in the next lesson. Signing off for now.